Okay, just quickly going through a chemistry paper. This is June 2015. Okay. So, multiple choice. Example of a non-metal. All these are metals, so we're looking at carbon. They always put carbon in there because that is the one that conducts electricity. Next question. Scanning it. Coloured dyes, so I know they're going to be asking about chromatography. Substance that remains in X. Well, that is going to be the residue. It resides, it stays there. If they ask for this one, that would be the filtrate. When a hydrocarbon burns in a good supply of air, so that's the key one, good supply, so lots of oxygen. So a hydrocarbon, so the hydro will go to water, and the carbon will go to carbon dioxide. So we'll keep carbon dioxide and water. It would only be carbon monoxide if it was a poor supply of air. To reduce the acidity, so make it less acidic, make it more neutral. So you know vinegar is an acid. Compost fertilizer, maybe you're not quite sure about them. Lime, in this case, it means limestone. So it's not lime like citrus, it's not acidic. This one is actually alkali. So that would neutralize. This one, so you can only use these to answer your questions. And okay, so an element, so you could have nitrogen, hydrogen, oxygen. A hydrocarbon, there is only one there, that is methane. Is flammable, so you could talk about methane gas, that's the Bunsen type stuff. You could talk about hydrogen, as you know that burns. We can't say oxygen. Okay, oxygen helps and supports burning, but it's not flammable. Read like slow splint, obviously going to be oxygen. Most abundant gas in the atmosphere is going to be nitrogen, 78%, oxygen 21%, carbon dioxide 0.03, something like that. Okay, so we've got diagrams of atoms and molecules here. So a pure element made of molecules. Okay, this one will be a pure element, but that's just made of atoms. Molecules is when you've got more than one atom stuck together. So in this case, we have got a pure element made of molecules there. Pure compound. Okay, so we're looking for different elements chemically joined together, but it's got to be pure, so there's only that one type in there. So you could choose D for that one, or you could do B. Mixture of two gases. So here we've got three different things. Here we've got two different things. So this is the only one it can be F. Carbon dioxide, so we're looking at CO2. So in this case, CO2. Next one. Red cabbage indicator. That's an experiment you have done. So this is the colour it goes in different solutions. So state the colour in a neutral solution. So looking at 7, so we would say it is purple. In a weakly alkaline solution, so above 7 but not too much above it, so 9, so we would say it's blue. Name a substance that could be added to turn it red. Okay, so we're looking to move it down towards the acidic scale. You can't just put acid there. We're after a full name for a substance, so you could talk about vinegar. Talk about citric acid, hydrochloric acid, sulfuric acid, nitric acid. Don't just leave it vague. Don't just put an acid. Yeah. What name is given to a substance that behaves like this? Well, it's an indicator. Describe a method where you could extract the dye from the red cabbage. 3 marks. Okay, so get plenty of stuff down here. So first thing you do is you chop it up smaller. You're increasing the surface area. You would add water to it to extract the colour from the red cabbage. You would warm it up. You would stir it. Yeah, all of those things will allow you to extract the dye, and then at the end you're going to filter it, so you're just left with the liquid. So this is about hydrocarbon, propanone. Lots of information up here, so they're obviously going to refer back to this in the questions. Name the 3 elements that make up propanone. Propanone, CHO, so carbon, hydrogen, oxygen, elements we're looking for. How many atoms are in one molecule? 3 plus 6 is 9, plus the 1 for the oxygen is 10. 3 elements, but there are 10 atoms. How can you tell that it's a liquid at room temperature? Room temperature, about 20 degrees Celsius. So it is above freezing point, but below boiling point. So it's going to be a liquid. 2 reasons why it's important to keep the stopper in propanol. Very obvious one. It is flammable. It also evaporates at a low point. So if you don't leave the lid off, you're going to lose lots of that liquid by evaporation. Measured out 10 centimeters cubed of propanol into a measuring cylinder. What would the mass be? So this one, they're actually asking you to use a bit of physics. So we've got mass, we've got volume, and we've also got the density up here. Okay? So we can work out the mass using my dog vomits. Okay? This one, a metal, magnesium, and we've got an acid. So straight away I'm thinking metal and acid, MASH, yeah, metal, acid, produces a salt and hydrogen. So name the gas produced. Well, obviously hydrogen. Describe how you could test for this gas. Now, very often people will put things like squeaky pop and then leave that blank. Okay. They're giving us 2 marks. All right. So I would say use a lit splint, result, squeaky pop. Okay. Or just, test with a lit splint and give us a squeaky pop. If you're not sure, write both of those, write it twice, just to make sure you get the marks. Don't give them any opportunity to miss out on the mark. So she's capturing the volume of gas and creating this. Obviously, they're going to ask you to draw a graph at some point. Okay, this is the independent. They decided when they were going to take the sample. This is the amount of gas. We had no idea what that was going to be. We did know what time we were going to use. Okay, so that's the independent and that's the dependent. Suggest how the apparatus is shown to make it more accurate. If you look at it, we're using a test tube. So to make it more accurate, you'd probably use a syringe. You could even use a measuring cylinder, I suppose. Okay. So plot the remaining points. So obviously you go up there and you plot them, and you're going to get a graph where it levels off at some point. Okay, I'm not going to bother drawing it in, but you get the idea. Oh, let's see that. So using my stick thing up here. Okay, so it's probably going to go up here, and then it's going to level off at some point up there. I'm not looking at the figures, so don't worry about it. Okay, so we're going to get something like that. Okay, just move it down. Just ignore that. So it's a line or a curve of best fit. So they've actually helped you out by saying that. Obviously, I wouldn't do it as a straight line. I'd do it as a curve, as I was drawing it. This graph shows about the reaction, as I was saying. Steady increase until it reaches the maximum at whatever that number is, etc. State the time at which the reaction stopped. Now, very often people think, oh, it's finished here. The reaction's actually finished up here, hasn't it? Yeah. So the earliest point it stops. Write that in. And then sketch a line if you're using the same volume but more concentrated hydrochloric acid. So let me put that back up there. Let's use a different colour. Okay. Now, if you use it more concentrated, it's going to react faster, isn't it? Yeah. So this line is going to be much more steep, but it's only got the same amount, so it's going to go to the same height. So you're going to get something like that. Key point is it reacts faster, so you're going to get a much steeper line. Okay. Let me try and get rid of this slightly sharpish. Sorry about this. Technology is not brilliant. Just gets that line. I'm giving 2 marks for that. Yeah, a lot of marks for that. Next question. Lots of stuff about copper here and the different reactions and formulas. So copper carbonate. Heat it, turns to a black powder. That's a black powder, copper oxide. So if we started off with copper carbonate and ended up with copper oxide, we've lost carbon dioxide. So why does the mass decrease? Because you lose because you lose carbon dioxide. Name of this reaction, if it's a carbonate and all you're doing is heating it, then it's going to be decomposition. Word equation, that's copper carbonate, that's copper oxide, and we need to add carbon dioxide. So it would be CuCO3, arrow, CuO plus CO2. When copper oxide is added to acid, it forms a green solution. Let's have a look. The green solution. Is it going to be that one? Well, we're not adding carbon to it, but we are adding. We're using hydrochloric. We're going to add chloride to it, so we're going to do that. So what we're doing is this is an alkali. We're adding acid to it. As you know, acid and alkali, you produce a salt and water. So in this case, the salt will be copper chloride. And the other thing that's produced is hydroxide water. So the salt will be copper chloride and water. That is a neutralization reaction. Copper added to dilute sulfurate, there's no reaction. Well, as we know, copper is a very unreactive metal, so it's going to be a very slow reaction. If we put something like magnesium in there, as you know from your own experience, it fizzes, doesn't it? Rapidly. It's a more reactive metal. Put copper roof on a building and it turns black and then it turns green. Explain the two chemical reactions that have caused this. So we started off, let me just scroll back. We started off with copper and then it turns black. So obviously we have added oxygen to it. So it's out on the roof and it's becoming oxidized, so it turns black. And then it turns green. Okay, we're not adding chloride to it, but we might be adding some of the carbon dioxide that's in the environment to it. So we're producing copper carbonate, so it's turning green. And question 8, they love asking questions about metals and their different properties. So 2 properties make this useful. So it's cheap. It's got a high melting point. Yeah, you don't want it to melt when you put it in the oven. It's a good conductor of heat. It's malleable. You can shape it, as you can see around here. So anything like that would do. It's wondering whether it's made of aluminium, tin, or silver. Why is it unlikely to be made out of silver? Are we going to use silver to cook our food and then throw it away? No, we're not. Far too expensive. Reactivity series here, and we are being asked to create an experiment to find out if it's made of tin or aluminium. Okay. Okay, so you can see the relative reactivity of them, and he's using zinc sulfate. So zinc is more reactive than tin, less reactive than aluminium. So you're going to use a sample and test it. What we're looking for is displacement, so we look for a displacement reaction. The aluminium would not displace the zinc, so there'd be no reaction. Sorry, I do apologise. The aluminium would displace the zinc because it's more reactive, so we'd see little bits of zinc appearing on the bottom. Tin, on the other hand, is less reactive, so there would be no displacement. So you could look for signs of fizzing, you could talk about a temperature change. So for 4 marks, you need to be talking about all these things, yeah? You would repeat and take the mean. You would use the same strength of zinc sulfate solution. You'd use the same amount of aluminium and tin. You'd make that accurate by measuring it with a weighing scale, something along those lines. And safety precaution, we're using acids and liquids, so we're going to put goggles. Okay, thank you very much.